In 1966, a military rocket was launched from the Plesetsk Cosmodrome in northern Russia. Plesetsk was one of the most secret sites in the Soviet Union. It did not appear on maps, and its existence was officially denied for years. From there, the USSR launched military satellites and tested ballistic missile technology. This launch did not go as planned. Shortly after liftoff, the rocket failed. It lost stability and broke apart in the air. Instead of reaching its intended trajectory, fragments of the rocket fell back to Earth over a wide area, including forests, rivers, and small rural settlements. The event was not announced. There were no emergency warnings, no evacuations, and no public statements. For people living in the impact zone, the incident appeared sudden and unexplained. Some reported loud noises in the sky. Others later found metal debris scattered across fields and forest paths. What made this incident especially dangerous was not the explosion itself. It was the fuel. The rocket was powered by Heptyl, also known as unsymmetrical dimethylhydrazine, UDMH. This chemical was widely used in Soviet military rockets because it was easy to store and worked reliably in cold conditions. For engineers, it was practical. For civilians, it was extremely dangerous. Heptyl is highly toxic. Even small amounts can contaminate soil and water. When released into the environment, it evaporates quickly, forming poisonous fumes, and also seeps into the ground, where it can remain for years. Exposure can damage the liver, nervous system, and respiratory organs. In 1966, none of this was explained to the people living nearby. They were not told what had fallen from the sky. They were not warned to avoid water sources or farmland. Life continued as usual, even as the contamination spread invisibly through the environment. The rocket never reached space, but what it left behind would remain on the ground for much longer. The fuel used in the failed 1966 launch was Heptyl, officially known as unsymmetrical dimethylhydrazine, UDMH. For the Soviet military, Heptyl had several advantages. It could be stored for long periods without losing effectiveness. It ignited easily and functioned reliably in low temperatures, a critical factor for launches from northern sites like Plesetsk. From an engineering perspective, it was efficient. From a medical perspective, it was extremely dangerous. Heptyl is a highly toxic chemical. Even small quantities can cause serious health effects. It enters the body through inhalation, skin contact, or contaminated water. Once inside, it affects the liver, central nervous system, and blood chemistry. According to later medical studies, exposure to Heptyl can lead to acute poisoning, liver damage, neurological disorders, increased cancer risk. When a rocket using Heptyl breaks apart, the fuel does not simply burn away. Some of it evaporates into the air as toxic vapor. Some falls to the ground as liquid droplets. Rain and snow carry it into soil and groundwater. In cold climates, decomposition is slow, allowing contamination to persist for years. Estimates from later investigations suggest that several tons of toxic fuel were released into the environment during rocket accidents of this type. Even a fraction of that amount was enough to contaminate large areas of land. At the time, safety protocols for civilian exposure did not exist. The USSR classified information about rocket fuels. Local authorities were not trained to identify chemical contamination from military launches. Medical personnel were not informed about the specific risks. As a result, symptoms appeared without explanation. People reported dizziness, headaches, nausea, and skin irritation. Livestock became ill or died unexpectedly. Wells and rivers developed unusual tastes and odors. These signs were treated as isolated incidents. No connection was officially made to the rocket failure. The fuel was invisible, odorless in low concentrations, and unfamiliar to those affected. Without information, there was no way to respond appropriately. Heptyl did not create a dramatic disaster. It created a quiet one. And in 1966, quiet disasters were the easiest to ignore. The debris from the failed 1966 launch did not fall in a single location. Fragments of the rocket and unburned fuel were scattered across a wide area surrounding the Plesetsk Cosmodrome. Forests, rivers, wetlands, and small rural settlements all fell within the impact zone. According to later estimates, the contaminated area extended tens of kilometers from the point of breakup. The exact boundaries were never officially published at the time. Maps showing impact zones were classified. However, archival materials and post-Soviet investigations suggest that dozens of square kilometers were affected by toxic residue. Heptyl contamination did not remain on the surface. Rain and snow carried the chemical into the soil. From there, it entered groundwater and surface streams. In rural settlements, many households relied on wells and nearby rivers for drinking water. There was no filtration, and no warnings were issued. Environmental measurements conducted years later showed elevated levels of toxic compounds in soil samples taken from former impact areas. In some locations, traces of heptyl derivatives were detected decades after the initial accident. The effects on animals were immediate. Farm animals grazing in contaminated fields became ill or died within days or weeks. Fish disappeared from small rivers and ponds. Hunters and villagers reported unusual behavior and sudden deaths among wildlife. For people, the consequences were slower and harder to recognize. Residents reported symptoms such as persistent headaches, nausea and dizziness, chronic fatigue, skin and respiratory irritation. Local clinics treated these cases individually without identifying a common cause. Doctors lacked information about chemical exposure and were not informed about the rocket accident. The absence of visible destruction made the situation more confusing. There were no burned buildings or blast craters in most areas. Life continued normally on the surface. Children played outdoors. Crops were planted and harvested as usual. Contamination moved quietly through water and soil. In some villages, metallic fragments were collected and repurposed. Pieces of rocket debris were used as building materials, tools, or scrap metal. People did not know the origin of the metal or the danger associated with it. Handling contaminated debris increased exposure risks. No evacuations were ordered. No agricultural restrictions were imposed. The territory was not marked or fenced. Officially, nothing had happened. The impact zone existed only in documents that were not meant to be seen. For the people living near Plesetsk in 1966, nothing officially changed. There were no public announcements. No instructions were issued to avoid certain areas or water sources. Schools, farms, and local industries continued to operate as usual. From the perspective of daily life, the rocket failure did not exist. Most residents did not know that a military launch had failed. Plesetsk itself was a closed area, and information about activities there was tightly controlled. Villagers were accustomed to seeing aircraft and hearing distant sounds, but were rarely told what they meant. When debris appeared, it was treated as unexplained, but not dangerous. Medical care followed routine procedures. Local doctors treated symptoms individually, without context. Headaches, nausea, and fatigue were attributed to stress, poor nutrition, or seasonal illness. Without knowledge of chemical exposure, there was no basis for further investigation. People continued to use local water. Wells, rivers, and small streams remained the primary sources for drinking and cooking. Livestock drank from the same sources. Fields irrigated naturally through rainfall absorbed contaminants without visible signs. Children were especially vulnerable. They spent more time outdoors and were more sensitive to toxic exposure. However, childhood illness was common in rural areas, and no unusual patterns were officially recognized at the time. The lack of warning was not accidental. Information about rocket fuel and military accidents was classified. Even local authorities were often excluded. Acknowledging contamination would have required explanations, evacuations, and long-term support, actions that contradicted the culture of secrecy surrounding military programs. As a result, responsibility was fragmented. No single institution was tasked with monitoring health effects. No environmental assessments were shared. Complaints from residents, when they occurred, were handled locally and quietly. Years later, some residents would recall unusual events from that period: sudden livestock deaths, persistent illness, areas where crops failed repeatedly. At the time, these were treated as coincidence. Only retrospectively did patterns begin to emerge. In 1966, those patterns remained invisible. The people most affected by the accident were the least informed about it. They lived inside a contaminated zone without knowing it existed. In the Soviet Union, military secrecy was not an exception. It was a standard operating principle. Rocket launches, failures, and technical details were classified by default. Information was shared on a strict need-to-know basis. Civilian safety was secondary to the protection of strategic programs. The 1966 accident near Plesetsk followed this pattern. Internal reports were written and circulated within military and scientific institutions. Environmental impact was assessed at a technical level, but findings were not released publicly. The existence of contamination did not trigger public health measures. This approach was not unusual. Admitting failure carried political risk. It raised questions about competence, safety, and accountability. Acknowledging civilian exposure would have required evacuations, compensation, and long-term monitoring, all of which implied responsibility. Instead, the system relied on silence. Local officials were instructed not to discuss the incident. Medical staff were not informed about the cause of symptoms they were treating. Environmental data remained classified. Without documentation, there was no basis for public discussion. The absence of information created a feedback loop. Because no official problem existed, no official solution was required. Complaints could be dismissed as anecdotal. Patterns could be treated as coincidence. Over time, memories faded and attention shifted elsewhere. Plesetsk itself remained invisible. The Cosmodrome did not appear on maps until years later. Its activities were officially denied. Without acknowledging the site, discussing its accidents was impossible. For residents, silence became normal. People adapted to uncertainty. Illness was managed individually. Losses were absorbed privately. There was no framework for collective response. Only decades later, after the collapse of the Soviet Union, did documents begin to emerge. Environmental studies, declassified reports, and journalistic investigations revealed what had been known internally for years. Rocket fuel had contaminated large areas, and civilians had been exposed without warning. By then, the immediate moment for prevention had long passed. What remained was documentation, and a history that had been deliberately left incomplete. The long-term consequences of the 1966 accident near Plesetsk became visible only years later. After the collapse of the Soviet Union, restricted archives were partially opened. Environmental researchers, journalists, and regional authorities began to study former rocket impact zones. What they found confirmed what local residents had suspected for decades. Soil samples taken from areas where rocket debris had fallen showed elevated levels of toxic compounds, including breakdown products of Heptyl. In some locations, contamination was detected 20-30 years after the original incident. Heptyl does not remain chemically stable forever. Over time, it breaks down into secondary substances, some of which are no less toxic than the original fuel. These compounds can persist in soil and groundwater, especially in cold northern climates where natural decomposition is slow. Health data was harder to reconstruct. There were no systematic medical records linking illness to rocket fuel exposure. However, retrospective studies indicated higher rates of liver disease, neurological disorders, and chronic respiratory problems in populations living near known impact zones. These findings were never officially labeled as consequences of a specific accident. Instead, they were described in general terms, without direct attribution. Responsibility remained diffuse. Compensation programs were limited or non-existent. Cleanup efforts, when they occurred, were incomplete. In later years, some contaminated areas were fenced off or marked. Debris was collected and removed. However, full decontamination of soil and water was rarely achieved. In many places, people continued to live and farm on land affected decades earlier. The 1966 accident did not change policy immediately. For years, rockets using Heptyl continued to be launched, and spent stages continued to fall over populated regions. Only much later did alternative fuels and revised drop zones reduce civilian exposure. The incident near Plesetsk became part of a larger pattern. It was not the largest rocket accident, nor the most dramatic. It did not produce images that could not be hidden. Its danger was gradual, chemical, and largely invisible. That is why it remained unknown. The rocket failed once. Its consequences lasted much longer.